let's talk about the third law of thermodynamics. So yung statement ni third law of thermodynamics, it states that the entropies of all perfectly crystalline substances are the same at 0 Kelvin. Yung 0 Kelvin, yan yung tinatawag nating absolute temperature. Now, ibig sabihin yan, if ever we can achieve this hypothetical 0 Kelvin, lahat daw ng perfectly crystalline na substance will have the same entropy. And hindi natin sinasabing zero yung entropy. But we can assume that the entropy at that point is zero. Pero ang sinasabi lang natin lahat ng crystalline substances na perfect will have the same entropies at this point of absolute temperature. However, we cannot achieve absolute zero temperature. So this is absolute zero temperature. The reason is that if your temperature approaches 0 Kelvin, ang nangyayari is the work needed for you to do that will approach infinity. Ibig sabihin, habang palamig ng palamig, nag-i-increase substantially yung kinakailangang work the colder you try to go. So it's impossible to achieve absolute zero temperature. And my favorite statement for this law is yung sinasabi natin na there's no such thing as perfect. Okay? Halimbawa, meron kang perfectly crystalline substance. Although again, you cannot achieve that because you cannot achieve 0 Kelvin temperature. But let's say, meron ka nung substance na yun na perfectly crystalline. Nangyayari is, yung thermodynamic processes, they create such imperfections. So, expansion, cooling, whatever, sila yung nagkikreate ng imperfection. Okay? So, yun yung implication ng third law of thermodynamics. Now, interested kasi tayo before in calculating the change in entropy, right? So, we try to calculate the change in entropy. Pero, what if we wanna calculate the absolute entropy for a certain process? Okay? So, is there such thing as absolute entropy? So, yun tinatawag natin na third law entropy. Okay? Or yun ngang sinabi ko na absolute entropy. So, how do we achieve this? Unang-una, you need to first set a value, like a common value for entropy at 0 Kelvin. So, usually, yung entropy natin, sinaset na at 0 Kelvin, right? At 0 Kelvin, we set at that as 0. Okay? And this is just for convenience, no? The reason is that we can obtain the absolute entropy or third law entropy of any process by comparing it with the entropy at the lowest temperature na 0 Kelvin. Okay? Now, again, this is just for convenience. Pwede kasing hindi talaga 0 yung entropy at that point. But the reason why we chose that as 0 kasi, if you recall yung Boltzmann definition ng entropy, so entropy can be calculated by K, which is the Boltzmann constant, times the ln of your microstates or the number of microstates. Now, at absolute temperature na 0, ang number of microstates natin ay 1. Kasi at absolute 0 temperature, all molecular motions cease to exist, right? So, ang ln na 1 is 0. Therefore, it will bring you to S being equal to 0. So, yan yung assumption natin. But again, there's no such thing as perfectly crystalline. So, kahit na nasa 0 Kelvin ka na, pwedeng may residual entropy ka pa rin. Okay? Now, ano yung implication niya? So, let's say, I have a process which I will illustrate using a graph. So, what I will do is, I will plot for that process yung temperature in Kelvin, no? Absolute, at yung C over T. Okay? Heat capacity divided by T. So what will happen is, at 0 Kelvin, so this is your temperature, at 0 Kelvin, which is the origin, right? Pwedeng zero din yung y-axis value natin or pwedeng meron. Okay? Kung meron, yan yung residual or natitirang entropy at 0 Kelvin because of the fact that there is no such thing as a perfectly crystalline substance. But let's say now we increase the temperature to a certain temperature called T sub F. And T sub F, you know what it represents. So, ibig sabihin yan, temperature of fusion or melting. So, melting temperature basically. Ituloy lang natin yung graph hanggang sa ma-achieve niya yung, let's say, T sub B or boiling temperature, boiling point. Okay? And so on. So, this is now your solid state hanggang dyan sa fusion or melting temperature. Then you have the liquid state between T sub F and T sub B. And also, you have your vapor or gaseous state beyond the boiling temperature. Now, in order for you to calculate the absolute entropy, it's actually the area under the whole curve. Yan ang absolute entropy. Okay. Now, mathematically, to calculate the absolute entropy at any point or at any temperature, so all you have to do is, unang-una, i-add mo yung entropy at T equals 0 Kelvin kung mayroon man. Again, we usually assume that to be 0, but if there is a value, then go ahead and use that. Plus, at that temperature 0 Kelvin hanggang sa tinutukoy nating temperature, okay, for a particular substance, so integral, use that limit of Cp over T dt. So, yan yung ating equation to calculate the absolute entropy or the third law entropy. And sometimes we also call this the Kirchhoff's law for entropy. Now, what if we want to determine, okay, let's determine the absolute entropy for water. Okay, ibig sabihin, from 0 Kelvin, yun nga yung definition natin ng absolute entropy, magsisimula ka sa 0 Kelvin to a certain temperature T Kelvin. So, how do we calculate the absolute entropy for water? So, if you're interested to calculate the molar entropy of water at that particular temperature, so i-add mo yung entropy na residual, ibig sabihin T equals 0, kung meron man yan, plus, you have to integrate with the limit from 0 to the melting temperature, okay? Kasi nga, nagsisimula siya sa ice state. So, let's say this is at 1 atmosphere. So, 0 Kelvin, malamang yellow na siya nun. So, hanggang dun sa melting point niya, which is T sub F, all you have to do is integrate yung heat capacity nung ice divided by T, okay, dt. Plus, after you reach that point, which is the melting temperature, okay, magkakaroon na ng melting, of course. And during that phase transition from ice to liquid, ang entropy can be calculated by dividing the entropy or enthalpy rather of fusion by the temperature of melting. Now, once the phase transition happens to liquid, ang mangyayari is you want to determine the entropy of the liquid state. Okay? So, ito yung ating magiging expression. And the limits will be from the melting temperature up to the boiling temperature. Now, liquid pa lang yan. So, once it reaches the boiling temperature, magkakaroon ng another phase transition, which is vaporization. So, you have to divide the enthalpy of vaporization by the boiling temperature. That's how we get that kind of phase transition entropy. And lastly, from said boiling temperature to the particular temperature na hinahanap natin, T, we can integrate Cp, which is that of a gas or vapor already, over T dt to calculate the entropy for reaching that temperature. Okay? So that whole thing now, this long equation is how you would determine the absolute entropy of water from 0 Kelvin to your desired temperature. Of course, if your desired temperature is less than the boiling temperature, of course you will stop at the melting enthalpy plus yung fusion temperature natin or melting temperature up to that particular temperature na lang. So, let's have an exercise. Let's calculate the entropy change for the process below. Let's do that both for the system and the surrounding. So, we have water, okay, at liquid state and negative 10 degrees Celsius yung kanyang temperature. So, you will transform this state to water at solid or ice at the same temperature, negative 10 degrees Celsius. And you will do this at 1 atmosphere temperature, or pressure rather. And you're given here yung ibang kailangang data, such as yung heat capacity ni liquid water, tsaka ni ice, and also the enthalpy of freezing, which is minus 6,005 joules per mole. So, ang ibig sabihin ng problem na to is that, let's say you have liquid water, and may draw an illustration. So, this is your water. Now, negative 10 daw yung kanyang, negative 10 degrees Celsius yung kanyang temperature. So, alalahanin ninyo na 1 atmosphere yung pressure dito. So, yung water at negative 10 degrees Celsius supposed to be solid siya. Pero, let's say, nagawa natin ng paraan na maging liquid siya. Okay? Tapos, ang gagawin natin is, we will form ice. Okay? Kasi nga solid yung product natin dito. At negative 10 degrees Celsius. Now, this state for water at negative 10 degrees Celsius, which is ice, it's natural for it, right? So, basically, ang tanong dito, ano yung entropy for this transformation? Or, another way to put it is, spontaneous ba yung transformation na to? And intuition says, yes, it should be spontaneous kasi yung ng negative 10 degrees Celsius, ice talaga dapat yan. So, kailangan, the process will go forward. But let's see, let's calculate the entropy change. And from the entropy change, we'll be able to determine whether the process is favorable or not. Now, this process can be broken down into different steps and walang problema yon kasi entropy is a state function. So, kahit na kung ano-anong daan ng process niyan, basta you produce this process na required, wala namang problema. So, let's outline all of these steps. So, probably the first process that will happen is yung water natin, okay, na magsisimula sa liquid at negative 10 degrees Celsius. Okay? Maybe, ang gagawin muna natin is, dadaan muna siya sa state kung saan liquid siya, pero we will bring it to 0 degrees Celsius, which is the melting temperature for water at 1 atmosphere pressure. Okay? So, for this process, we will calculate the entropy later. Now, from water at the liquid state and 0 degrees Celsius, ang magiging susunod na step will be water na solid na or ice at 0 degrees Celsius. Okay, so basically phase transition yan. And later on, to calculate the entropy change, you will need to use the enthalpy of freezing. And lastly, from water in the icy state and 0 degrees Celsius, we will bring this to a state wherein yellow pa rin siya, pero bababa lalo yung kanyang temperature to negative 10 degrees Celsius. And if you add all these steps up, okay, ang makakancel dito, so this is basically parang Hess law, right? So this will be cancelled out. Also this. So what process have you created here? So ang natitira is water, liquid, negative 10 degrees Celsius, forming water, solid, negative 10 degrees Celsius, which is our net reaction or process na hinahanap natin. Okay? So if you take the total of all the entropies here, yun na rin yung entropy ng process na to. So how do we calculate the entropy now for each of these? So sabihin natin delta S1, and let me probably use another color here. Okay. So delta S1, this is delta S1. And to calculate for the entropy change for this process, so ang nangyari lang naman dito is the same state pero nag-iba ng temperature from a lower temperature to a higher temperature. So integral of from lower temperature of 263 Kelvin to a higher temperature of 0 degrees Celsius or 273 Kelvin times Cp, and the state here is liquid, so Cp or heat capacity of liquid divided by T dt. So, magiging integral 263 to 273. Ano ba yung heat capacity ng liquid natin? Given naman yan. That's 75.3. Right? So, constant siya. Tapos, yung dt over T, ang integral niyan will be ln of T2 over T1. Right? So, T2 is 273. T1 is 263. So, ang makakuha mong value dito will be 2.81 joules per Kelvin per mole. Next, yung pangalawang process, ano yung kanyang entropy change? So, this is basically a phase transition process. So, ang kakalculate natin dito is phase transition entropy, and the phase transition here is freezing. So all you have to do is divide the enthalpy of freezing by the freezing temperature. Okay, so that would be negative 6,005 divided by 273 kasi yung melting temperature. So that would be negative 21.99 joules per Kelvin mole. And lastly, to calculate the change in entropy for the third process, change in temperature pa rin yan. The same state, which is solid. So, integral from 273 back to 263 Kelvin of Cp of ice divided by T dt. This will become, ano ba yung Cp of ice? 36.8. Tama ba? Yes, 36.8. Ln of 263 divided by 273, and you will get negative 1.37. Okay. I have to erase this part here sa entropy change 1 kasi yun na yung sagot. Yun yung ibig sabihin, yung integral or yung ln dito is the product already of the integration. Okay. So 75.3 ln of 273 over 263. So yan na yung integral basically. Anyway, now you have the three entropy changes, and all you have to do now is to calculate the sum. So the entropy for the system or the process is negative 20.6 joules per Kelvin mole. So kung titingnan nyo yung entropy, negative siya. Eh di ba ang criteria natin para maging spontaneous yung process is dapat greater than or equal to 0 yung entropy. Negative yan. So masasabi ba natin na not spontaneous yung process? Not so fast. Kasi ang nakalculate pa lang natin dyan is for the system. Remember, we need to calculate also for the entropy of the surrounding. But how the heck will you be able to do that? Entropy of the surrounding? Paano ko gagawin yon? So there's a wise way to do that, and what you can do is perform some sort of heat accounting. Okay? Heat accounting. Okay, so how do we do this? So let's outline the processes again. Nandito ulit yung mga processes and also the net sought after process. Now, what we will calculate next is yung heat nung process na yon. Bawat process na nakikita nyo dito. Heat. Kaya nga siya tinawag na heat accounting. So, what if I want to determine the heat for the first process? And let's call it Q1. So, si Q1, di ba, CP dt lang yan. Although that's really for enthalpy, but remember, constant yung pressure natin dito. If pressure is constant, enthalpy is the same as heat. So, ano ba yung CP ni ice? Ni liquid rather. So, 75.3 dt. That's just a change in temperature of 10. Right? So, 0 minus negative 10 is 10. So, 753 joules ang nakuha natin dito. How about for Q2? Remember, the second process is a phase transition. And specifically, freezing siya. So, remember, given naman kanina yung enthalpy of freezing, which is minus 6,005, right? So, yun na yun. Yun na rin yung heat of freezing. And lastly, for Q sub 3, or the heat from the third process, it's just CP dt pa rin, pero for ice na siya. The heat capacity of ice is 36.8, and then the difference in temperature is minus 10. So, negative 368. And ang gagawin nyo is you take the total of all these heats, no? At ang makukuha nyo dito, Q total will be minus 5620 joules per mole. Ano ngayon kung nakuha mo na yung entropy or yung heat ng process na ito? So, makukuha mo ngayon yung entropy ng surrounding. Okay? Equals what? It will be the negative of Q divided by the temperature. So, bakit ganyan yung formula natin? Kasi yung Q dito is yung heat given off by the process. Okay? By the process. Now, remember, whatever heat given off by the process, nag-gain siya ni surrounding. Okay? So, ang magiging value ngayon nung Q na nag-gain ni surrounding will be 5620 joules per mole. Okay? Kasi kung negative yung galing kay system, positive naman na masasabi natin kapag ang i-consider natin is si surrounding. And this is a genius way to calculate the entropy of the surrounding kasi kung ano yung pinasa mo kay o galing sa system, ma-absorb lang ni surrounding. So, makakalculate pa rin natin yung entropy ng surrounding. So, 5620 for Q, and let's divide it by 263. Okay, which is our temperature, negative 10 degrees Celsius. And you will be able to get here 21.4 joules per Kelvin mole. And to get the total entropy, or yung sinasabi nating entropy ng universe, remember, it's the sum of the entropies for the system and the surrounding. And dapat mag-greater than or equal to 0 yan. For the system, na-compute natin kanina yan na negative 20. Kaya nga sinabi natin, spontaneous nga ba? Negative yan. Let's see. Yung surrounding naman, na-compute natin at 21.4. So the sum is 0.8 joules per mole. Therefore, we conclude that this process is spontaneous. Now, in the next video lecture, which will probably fall under module 2 already, there will be a way para malaman natin kung spontaneous nga ba talaga yung isang process without looking at the entropy of the surrounding. Okay? So, malalaman natin kung ano yon in the next video lecture.